Lesson 11, Volume. Our objectives for this lesson, much like our last lesson, we want to be able to define what we're talking about. In this case, we want to define volume. Secondly, you'll want to be able to calculate the volume of various regular shapes. Unlike the last lesson, though, we're going to be able to work with liquids. So you will also want to be able to determine the volume of a liquid using a device called a graduated cylinder. And using a graduated cylinder, you will be able to determine the volume of an irregularly shaped solid using a method called water displacement. Let's start with our definition. Volume is defined as the measure of how much space an object takes up. And space has three dimensions: length, width, and height. 2 lessons ago, when we took a look at length, we had one dimension, and it told us the length of an object, the width of an object, or it could tell us the height of an object. Then, when we did area, we got 2 dimensions, length and width. Space has 3 dimensions, length and width and height. So volume is going to give us all 3 dimensions. Having 3 dimensions, the units are going to be some sort of length cubed. Things like meters cubed, centimeters cubed, or feet cubed. Where the cube is much like the square in area. It's a notation. It is nothing mathematical. We don't cube the number. The shapes that we are going to be working with are regular shapes, much like we did for area, cubes, spheres, and cylinders. The formula for a cube is length times width times height. For a sphere, it's 4 times pi times the radius cubed divided by 3. And for a cylinder, it's the area of the base, pi times the radius squared, times the height. Now, just like with area, when we found the area of a circle, we put 3.14 in for pi. We want to do the same thing here, because having a measurement in terms of a decimal is going to be far more useful than keeping our answer in terms of pi. So always multiply pi out. You will want to put these formulas on your formula card under Basics, under a heading of volume. Let's try an example. The shape that I chose for this example is a sphere because I'm assuming that's the one you have the least experience with. So the first thing we do is put down our formula for the volume of a sphere. Next, we substitute our values in. 4 times 3.14 times 2 cubed divided by 3. Then we get an answer, 33.5 centimeters cubed. Notice that the cube is a notation telling us that we have 3 dimensions indicating volume. We don't cube the 33.5. And that is our final answer. Let's move on to liquids. Liquids are a little bit different than solids in that they take on the shape of their container. And as such, we can't really measure their length, their width, or their height. So volumes of liquids are usually going to be given in terms of liter, because they have no definite shape. The device that we usually use to measure the volume of a liquid in science is called a graduated cylinder. It gets its name because it is a cylinder and it is graduated. By graduated, we mean that it is broken up into smaller parts. One of the problems that we run into when measuring a liquid is that most liquids stick to the sides of their container or adhere. That being the case, we end up with a curve that forms on the top of the liquid. The name of this curve is called a meniscus. So the meniscus is the curved surface that forms on the top of the liquid because some of it adheres to the sides of the container. You may have heard of the term meniscus before in relation to your body. You may have heard of your meniscus in your knee. It's a curved piece of cartilage between your femur and your tibia. So the word meniscus means curve. When you are using a graduated cylinder, it might look something like this. So notice how we have this curve that is formed. The volume of the liquid should always be read from the bottom of the meniscus, so the bottom part of the curve. When you are reading a graduated cylinder, every graduated cylinder is different, and you will have to analyze it to determine what the markings mean. In this particular case, you could see that we have a 20 and a 30 with 10 lines in between. Therefore, each line represents 1 milliliter. That may not always be the case, so make sure you look at each graduated cylinder individually. You can see that the bottom of the curve is somewhere between the third line and the fourth line, so we can estimate that the reading for this graduated cylinder is 23.5 milliliters. If we have an object that we don't have a nice regular shape for, like a cube or a sphere or a cylinder, we could still determine its shape using a method called water displacement. The first thing that you do is you fill a graduated cylinder with some water. Next, you measure the amount of water. Then place the object in the water. When you place the object in the water, it is going to displace the water and the water level is going to rise. So you now measure the new amount of water. You subtract the two water levels and your answer is the volume of that irregularly shaped solid. Let's see how this works. In the example, a person has a ring and needs to know its volume. She fills the graduated cylinder with 10 milliliters of water. She drops the ring in and the water level rises to 13.5 milliliters. So in order to find the volume of the ring, we take our original amount of water, 10 milliliters. We subtract it from our new volume, 13.5, and get 3.5 milliliters. Now, one thing that's odd about this is we're finding the volume of a ring. A ring is a solid, it's not a liquid, so we wouldn't normally keep it in terms of milliliters. As it turns out, a milliliter is the same thing as 1 cubic centimeter. So 3.5 milliliters is 3.5 cubic centimeters, and that would be our final answer. You could put this conversion of 1 milliliter equals 1 cubic centimeter on your formula card, or on your conversion sheet, or in both places.